Okay, finally, we're putting it all together. Generally speaking, the higher you throw the ball, the more energy it has. And for you to throw the ball, that means you've put more work into it. But if you throw it so high that it never comes back, that means that at that height, it actually has an energy of zero. It didn't do any work on the hole puncher. Work on the hole puncher is kind of our judgment for how much energy the ball had. If it did a little bit of work, it had a little bit of energy. If it does a lot of work, it had a lot of energy. If it does no work, that means it had no energy. So this is kind of weird. The higher and higher we throw the bowling ball, the more and more energy it has until it gets to zero energy. So if we switch it, if we bring it in that weird story I was telling you before, when you throw the ball, you're giving it energy, kind of like depositing money in a bank account. So the harder you throw it, that's like depositing more and more money. Here's the weird one. What if we deposit a whole bunch of money? You put a whole bunch of money in a bank account, and then when you check the balance, that bank account has $0. That was that whole moving away to university talk. If depositing money brings you to a zero balance, that means up until that point, you must have had a negative balance. So here's what's weird about gravitational potential or gravitational field energy. Gravitational field energy is going to be negative. There are going to be a bunch of negative numbers, and you can increase and increase and increase and get more and more energy, which really what it means is less and less negative until you get to the zero energy amount. We'll see it again when we do electricity, but for now, what we'll say generally is when objects are attracted to each other, which is what we're doing with gravity, then it takes a positive amount of work, or you have to add energy to separate them. If you don't do any work, then it's like you at the poker game, they're trapped. They're not allowed to leave each other's influence. But adding energy draws them farther and farther apart. If we get them so far apart that they don't influence each other anymore, then we say they have zero energy. So adding energy or doing positive work gets them to where they have zero energy. That means they must have had negative energy up until that. Maybe it'll make sense if I just make up numbers. So not doing any math or anything crazy, just making up numbers. Let's say when the bowling ball is close to Earth, it's got a really, really large negative value, like negative 100 million. That's a big negative number. Maybe if I throw the bowling ball so high, I give it some energy to make it go higher. Maybe if we get it to where the bird flies, I've given it some energy so it's got more energy than it did before. It's kind of weird because of the negative, but maybe it's got negative 99 million of joules. Negative 99 is actually a greater number than 100 million. If you had two companies you were looking at investing in, one had negative $100 million and another company had negative $99 million, although it's weird to think of it this way, the one at negative 99 million actually had more money because they were less in debt. If we keep going with it, maybe when we get the bowling ball up to the space station, the negative number drops to negative 80. Negative 80 is actually a bigger or more energy than the negative 99 and the negative 100 million. If we keep going higher and higher and higher, those numbers get less negative. They're getting larger, but really what that means is less negative. Negative 100 million, then negative 80 million. If we get a crazy high, negative 20 million. Crazy, crazy high, negative 1 million. Crazy, crazy high, we might get it till it's got zero. So adding positive amounts of energy separates the two masses, and if we get them so crazy far apart that they don't influence each other, we say they then have zero. Really what that means is when they're not crazy far apart, they're trapped in each other's influence, which means kind of like at a poker game, trapped because the amount of energy is negative. Okay, last little bit before we get to the math. In grade 11, we used E equals mgh, and we could manually set the EG equals 0 depending on the question. Often we gave you, I typed here pendulums, but often we gave you roller coaster questions. If a roller coaster starts 20 meters up in the air, how fast is it going at the bottom? For that, we would say that at its lowest point, the EG was 0. So we'd build up off of that. So when it's 20 meters high, we would plug in an HF20 and calculate our way through. We wouldn't say that the EG was 0 at sea level, because we're not comparing it to sea level. So we could arbitrarily choose our EG equals 0 amount in grade 11 using that MGH equation. Now it's going to be a little bit different. We're going to do some math and we're going to come up with a new equation, a new expression for gravitational field energy, universal. So it'll work far from Earth, close to work, it will work everywhere. But the 0 amount isn't arbitrary. The 0 amount is going to happen when these masses are so far apart that they don't influence each other anymore. And at every other position, the EG is going to be negative. The closer together they are, the more negative. The farther apart, the less negative, or the closer to 0. A poker player that's really in a lot of debt is really trapped at the poker game. Like if you owe some poker players, some mean, nasty people like $100, they're not going to let you leave. But maybe you're playing poker and I don't know, maybe different game, you're only down like 5 cents. You're still down. So in theory, you're trapped, but it's easier to escape when you're less negative or closer to 0. All right, I think that's enough yabbering on. It's all there typed out, so read through it again if you want. I'm going to pause the video again, and then the next little video, well, maybe what would be smart is if you watch the proof, but the next little video, I'll talk you through the math and the outcome of it.